So now we're going to do a short intro to the NPN bipolar junction transistor as a switch. So that's the symbol, but usually they don't have the names and should have the part number though. Arrow is pointing out, may not be circle. They come in the TO92 package most commonly right there. Check the data sheet for the pin layout. Do a Google search. Now we have it as a switch circuit. We have a load we want to switch. But with the NPN bipolar junction transistor, you need a little bit of base to emitter current to get a lot more collector to emitter current, as you can see there. If it has a gain of 200, which it may, then for 20 milliamps of current, you need at least 0.1 milliamps of current there. So we got more as long as the switch is closed there. If you do not have any base to emitter current, that's how you get it to not conduct right there. So you probably wouldn't use a mechanical switch, but you find some way that doesn't provide a lot of power to either produce a little bit of current or no current at all. So now in this video, we're going to take a short look at the PNP bipolar junction transistor. 2N3906 is one of them. There's the symbol. It may be that way or that way, but those are the pin numbers right there. Usually there's a part number next to it. So just like the NPN bipolar junction transistor, you need a little bit of base to emitter to base current right there, but it's going in the opposite direction of the NPN. So it works the same, but polarities are opposite. You need a little bit of base to emitter current, in this case emitter to base current, to allow many times as much collector current right there. So the load will set the current as long as the transistor is conducting enough. If it has a gain of 200, which it might, then you need about 0.1 milliamps of current to switch 20 milliamps of current. Or you could have higher right over there. So no current to the base, then there's going to be no current to the load right there. You wouldn't usually use a switch, you just use something else that either provides a little bit of current or does not. So now when you're dealing with switches such as bipolar junction transistors wired as a switch, we got the 2N3904. It's the NPN version, one of them. It can switch up to 200 milliamps of current. Other transistors can switch more or less. But in any case, you can see that the switch circuitry, the transistor, is on the low side. It's towards the negative supply right there. You need a little bit of base to emitter current to allow a lot more current to flow through the load over there, which is on the high side, where the collector is. When it comes to the PNP, there you can see its emitter is to the positive supply. So it is a high side switch. It's on the higher side of the circuit. You need a little bit of emitter to base current right there to allow a lot more current to flow down through the collector and the load right there. But that's going to the negative supply. So the emitter is to the positive supply. That's high side. And the emitter over here for the NPN is to the negative supply, that's low side. So now we're going to do a short intro to the N-channel enhancement mode MOSFET. This is a symbol that I like. Other people use other symbols and they do not like the symbols that other people use, but there's no universal symbol right there. So they make really good switches, but they aren't as common as bipolar junction transistors. The ones that I have are 2N7000 and so that's the one I use. But in any case, we have a channel and they're in a gate. They're separated. It's kind of like a capacitor. You make the gate more positive, the channel gets more negative. It becomes a good conductor, and in this case the load will be on. If you move the jumper to the ground right there, the negative voltage, it will turn the transistor off right there. So you make the gate more negative, the channel is more positive in a way, and that's, since it's N-channel enhancement, making it more positive actually restricts how well it conducts. It turns off, as does the load. So now we're going to do a short introduction to the P-channel enhancement mode MOSFET. So that's the symbol I use. There's no universal symbol. I have the BS250, and people that use other symbols don't like the symbols that other people use. Just a fact of life. So the ones that I have are in the E-line package right there, but they still have 3 pins. And that's the pin layout, so drain, gate, source. And so the source is to the supply voltage there. This depends just on the voltage at the gate for whether it conducts or not. So you give a high voltage right there. You can see I wrote off right there. That's because that makes the channel more N-like, more negative. And it's the opposite of the gate right there. And it's P-channel enhancement. If you move the switch to the on position there, to the negative supply right there, that makes the gate more negative, which makes the channel more positive. This is just a simplified way of explaining this. But that means it conducts better. It's going to conduct, and then the load will limit the current at that point. So now in this short, we're going to introduce the concept of sinking and sourcing when it comes to current. So we got a switch here. Generally, it's like switching circuits where you think of it. And you can see that's going to the negative supply. So we just analyze circuits as if current is flowing from positive to negative. So this is sinking the current flow right there. That LED will light up. This LED will not light up because there's a negative on both sides right there. If we move the switch up there, then the switch would be the source of current, and that LED would light up, which I drew over here. So yeah, we got a positive, so that's considered the source, and then the load headed to negative. Again, if we flipped it down here, then it would be sinking current, so we'd have positive up there going that way, be negative on both sides. That LED would not light up. So that's sinking and sourcing. Blue LEDs are brighter than red LEDs, so I got a higher value resistor limiting the current from that one.